The talk here is highly scalable microservice systems. So I'm going to ask you all individually. One of the challenges I face when I meet young developers is their obsession with building scalable systems. And how many times in your life have you had to build a system for 100,000 concurrent users? And is scalability just a pointless goal for most developers?
Hello? Okay, fine. Now it's working. Tried several times. Let me start. I don't know. Maybe I qualify as young or not. I don't know what your point of view on that one. Actually, yes, I did one for 200,000 concurrent users, not 100,000 concurrent users. So the design of a highly scalable system is really, really different from the design of whatever else. Now, you need to, those are very important non-functional requirements that you must take into consideration when designing a new system. Also, if you plan to do a big bang release, please don't do that. We did, but don't do that in the first step. So, yeah, that's, it happened. Most of systems don't need to scale. So the first rule of building high scalable microservice system is, do you really need to? This is the first question. Like, do you really, really need to? Like, it's a lot of complexities to scale. It's perfectly fine not to scale and writing a system that can't scale. First, this is my point of view on that one. Then after that, if you do, well, that's a long conversation.
I'd just like to add, I agree, but actually I probably would phrase it slightly differently. You need to define scale. For some people, scale might be it scales to 10 concurrent connections, not 10,000 or 100,000. But if you are looking at the 100,000 or 200,000, you absolutely need to consider that companies like Google didn't get it right overnight either. And in some areas, they're just getting it right today. It's not something you should launch into without thinking about what the issues are. Where are your potential scalability bottlenecks going to be? Because they may not be in the number of microservices or the language that you choose. They may well be in the network that you're going to deploy, which could be outside of your control. So if you have a fantastic, on paper, scalable architecture, and you deploy it onto an AT&T network in the US, for instance, it probably isn't going to scale anywhere near as your architecture could allow.
Let me help you with a definition of scalability that may lift the conversation. For me, a scalable application is any application where it's going to exceed the physical capabilities of a single box, right? Where I'm going to run out of bandwidth, run out of memory, run out of disk I/O. Effectively, I now need to build something that's distributed to address the loads and the demands of the system. So trivial 10 connection applications don't count. Anything I can run on my laptop, and you can run a lot of stuff on your laptop, right? You know, I've run very large web services on single instance databases in the past, and a single instance database will get you a long way. So think about in scalability in that context. And you may have built a 200,000 user system. How many have you built? 50, 100, or 2?
One.
One, exactly. That's my point. In 20 years of building application software, you may not be asked to do this more than once or twice.
I built one. I consulted with several different, so I'm a consultant. So I'm also a performance expert, whatever, on node.js. So I end up being called several times when there are performance issues. So that's why I've seen several of those things. But the most problem I'm facing most of the time, it's not something you are, you might be, guess what, as your first problem, most of the time for me is the network card. You can write the most fast code and whatever, but even if you've written your super fast code, you have only 800 megabits from that network card on that VM. That's what you get. That's the biggest thing you can buy. Well, with sanity. So yeah, that's my problem. So yeah.
Sure. So you mentioned young developers, and bless them, they're full of enthusiasm and they want to solve every problem under the sun. But not every problem under the sun has to be solved by every single person. Scalability is one of those. Just like authentication or security, you don't, as a developer, have to take on that problem and solve it yourself. There are other ways to solve the problem. What you do need to know as a developer is what are the things that make an application unscalable, and make sure you don't make those mistakes. Don't depend on some huge, great single point of failure, big back-end database. Don't depend on lots of state being shared over lots of things. Architect your application so it can be scaled, but scalability is as much an operations problem as a developer problem. So coach your developers on the right way to build code so that when it's deployed in production, it can be scaled. Just as you coach them how to write secure code, but when it's deployed in production, there are other measures as well to improve the security. Coach your developers that authentication is important, but they don't need to build all that stuff themselves. So look to the ecosystem, the platform you deploy on, help your developers to understand what are the tools around them that can help achieve those goals so they don't have to solve those problems themselves.
Clifton.
I'd just like to add one last thing. Scalability has not been a problem that's only happened today. Like I said earlier in the presentation, Cober, distributed systems, back in the day, back in the 1980s, distributed systems were the norm because the hardware that you had was really, really limited. You needed to move off that box as quickly as you could if you want to do more and more things. And I would absolutely say that people have been pushing the scalability threshold for decades. It's just that threshold keeps moving up. And things that we knew back in the 80s and 90s are extremely relevant today. We should not think that the scalability issues that we have today, cloud scale or Internet of Things scale, are new. There is nothing that we can learn from the past. We absolutely need to be learning from the past.
Okay.
So I guess the only thing I'll echo, similar to the previous comments, is I think as a young developer, you're best off focusing on the things that you can directly affect. Make sure that you understand first and foremost the thing that you're building. Make sure that you understand what the layers above you are doing. I mean, we ran a knowledge share session at TES recently where I explained the actual architecture all the way from our content delivery network all the way down through NGNIX to the services and the layers of caching that were available in the middle that you get completely for free, provided you understand how HTTP caching headers works. I was surprised by how many engineers didn't really understand that and didn't understand just how much performance gains they could get out of just doing the simple stuff right. So keep it simple. Don't do anything obviously stupid, the classic kind of N+1 stuff where you go and get a search result and then make 20 web service calls for every response. These sort of patterns that are, obvious foot guns that young engineers make. If you go after those, you'll get significantly higher performance gains than trying to be too clever. I mean, we run the entire Daily Mail off 4 web servers, 200 million monthly uniques.
Just hold the mic there for a second. So let's just assume for a second you are TES Global, and pretty much everything you put out there is going to have, I don't know what your concurrent user base is, but it's got to be tens of thousands at least, if not higher. And this is again for all the panel, but I'd love to hear your answer. How do you test before you go into production? How do you assess that a system can absorb the potential offered load?
We don't do any automated performance testing before things go live. Because of the way that our architecture is distributed across all of these verticals, we have very few single common points of pressure, I guess. The most obvious of those actually is we use NGNIX as a gateway and routing tier at the front of our architecture, much like as described previously. That's really the only thing that handles the entire traffic of the site beyond our CDN. And actually that operates at about 2% capacity on most days. So what we find is when we put new services into production, even if they have performance problems, they're pretty contained. We monitor them. If we think there's a problem that's significant enough, we roll back. If we think we can deal with it, then we move forward. But it's one of the advantages of having our system as distributed as it is in terms of these product verticals, is no one part of the platform is actually under significant load at any given time. We've sort of effectively distributed the load across the services.
Anybody else want to take that?
Sure, just not much I can add to that other than make it scalable and stick NGNIX in front of it.
Make it scalable and stick NGNIX in front of it.
I'm not going to say that. I want to say make it scale. No, understand your architecture. We automate as much as we can. Do continuous testing even after you've deployed. I don't know if any of you guys have looked at what Netflix OSS has. They have things like Chaos Monkey, Chaos Kong for testing and crashing things. And I think from a scalability point of view, you absolutely need to test for failures. You cannot wait until a failure really happens. And just look up some papers on Google and things they found with one of their critical services called Chubby, or things that Amazon and Netflix have done with things like Chaos Monkey. Fail your system regularly. Even if a failure does not occur, kill something, because you will find that something people find is very, very reliable and just will always be available. When it's not available because you didn't architect it thinking it would be highly available, everything else in your system fails. So I would seriously recommend, don't focus just on throughput, focus also on failing things.
I have one thing to add. One thing that we do when assessing, when tackling any performance problems is understanding what is the load that any single part of the system can take. So this is your baseline to some extent. You need to understand how much traffic your web server can handle, how much traffic your API or HTML rendering pipeline can handle. Now you have those numbers, whatever they are, all numbers are good. And then from there you can move on and assess how you can project how the system would work if there was if in the ideal world. Okay, now reality is really different. So those numbers will tell you at best what you can do. So this is the only thing you can test in isolation, because if you say, well, testing 200,000 concurrent connection, you can't, okay? It costs too much money. But what you can test, even on a nightly job, is how many concurrent connections, how many concurrent requests can a single instance of your box handle. And that's a number that you can monitor over time, and we have done it on several times in several projects, so that we run those performance testing every night, because they take some time. So and then you plot the graphs, and there's some very nice Jenkins plugins you can stick to plot diagrams from CSV. It's very easy to automate. And then you have this nice thing. You can track performance over time, and if you have introduced a regression. This is more against performance regression. It's really easy to create some problems on the caching layers, given that a lot of developers don't really understand HTTP caching. I'm going to refresh this. If there's anybody in the audience that don't have real-life understanding on how HTTP caching works and all the different on the chain of HTTP caching, go home, take a couple of days, run some good experiments out of this, because it's the secret sauce of scalability. You cache the hell out of it, more or less.
Sure. So another thing to add is understand the difference between external traffic and internal traffic. Internal traffic is generally fast, local network. It's much like the traffic that you would generate in a benchmark, but it can be very, very prone to spikes. And spikes can often be caused by failures, and those failures can cascade. So the Chaos Monkey approach is really important to understand where failures happen and what's the ripple down effect. But benchmarking and being aware of the kind of spikes that you're seeing can give you a fairly accurate first estimate as to how much internal capacity that you need. External network traffic's very different. You see much more concurrency, you see slower connections, so that's somewhere where you can make big benefits from doing edge caching or doing some sort of termination at the edge so that you can quickly translate those external requests into fast local requests.
Okay, I'm going to ask one more question. I'm going to throw it out into the audience for a couple of questions. What's the most surprising scaling problem you've come across? And I say this because having built a pretty large consumer product for online backup, we predicted scalability problems in all the wrong places. Our biggest problem in scaling that product was collecting real-time statistics. So what's the biggest or most surprising scalability problem you've come across in the businesses that you run?
Sure, so I'll throw one in first of all. Biggest mistake I made was not turning off debug logs and running out of disk within a matter of seconds.
People who believe that by throwing another thread at the problem, they can get more concurrency?
I would say thinking that some abstractions have no cost. This is a generic theme. Like, you know that long line costs some fraction of a millisecond to run or anything. But those, if you run it like 1,000,000 times per second, those add up pretty quickly. So the effect of one more debug line or 10 more log lines in there can actually affect your performance. So this is, I've said, oh, well, whoa, how do you solve this? Another thing is if you're running an agent for monitoring or collecting the statistics again and going again on the statistics, collecting the statistics, like disabling that gave us 100% performance boost. Like it's, be careful on what you put in there. So that's the other thing.
Yeah, I'd definitely echo that. I mean, the biggest surprises of my career have definitely been around not understanding the cost of abstractions, be that, you know, the cost of logging. I'll echo, you know, I think we've seen the biggest catastrophic failure we had at TES was when effectively our log stash infrastructure, which we used to log everything, that started slowing down, and we discovered it was a single point of failure. And it's one of these things, at the point at which it starts slowing down, you go, oh shit, that's obvious. But at the time, we just discovered that everything started slowing down, cascading failures, the whole thing fell over. We now have a very different logging infrastructure. And I think the other one, which is a common one these days, is, you know, the fact that you assume a service-to-service call has zero cost. And before you know it, you're making shed loads of these things. Your internal traffic's huge, and you start to get in the situation where, you know, cascading failure is a real problem in your live environment. So, you know, we definitely prefer local caches and sort of, you know, trade consistency of data over performance. We much prefer that model with messaging to keep those local caches up to date. But we do have a lot of service-to-service interaction, and things do fall over because of it.
Yeah, just something I referred to earlier, and you just referred to really as well. Getting the granularity of your service right, because if you make it too small, then you start to fire up lots of different services, and I have actually seen nano services. And even if the communication is not the bottleneck, firing them up, having them in memory, and then taking them down again when you're not using them will also kill you.
I have one more thing, in fact, that is quite, I hope it's quite interesting for everybody. And understanding what's your, the impact of your data model in the scalability of your application. So if you go relational or non-relational, it depends on your business, okay? It depends on the type of data you are managing. And using the wrong one can lead to a performance disaster. Just saying this because there is a very popular library in the Node.js world that does joins inside your application code. Now, this might seem weird to everybody, but it's very popular, downloads millions of times. Not want to shame anybody. But if you want to know, come ask me, and I will tell you not to use that library because it emulates the relational model on top of Mongo. So, not good. And I can spot a performance bug in less than 15 seconds. So it's quite funny when you do it live with somebody and in a minute you have pressures.
But can you find all of them in that time period?
No, but that's pretty much, if there is that library, you can find the bug in like, I destroyed a cluster, staging cluster, seamless production in 2 minutes after getting into it. It was from a Wi-Fi connection, so it was even, it was quite a feat, but yeah.
So we can take a couple of questions from the audience. Stick your hand up high, and please identify who you'd like to ask the question to, because that will help. We'll get to you next. There's a guy down the back here.
Hello, thanks for that. Awesome. My question is to the gentleman who's my age, who remembers Cober. I've been saying, we have a big poster in my office. It says Cober equals microservices. And the reason we've put that up there is to remind everybody to remember the history. But I'm a lone voice in this, and I actually think developing microservices is a lot harder than developing monoliths. And I just wanted to get the opinion on the skills that developers need, and if we have enough graduates who can actually implement this architectural pattern.
I'm not sure who you're referring to by a gentleman of your age.
The Cober guy.
Give me a clue here.
The Cober guy.
1, 2, 3, 4.
Somebody mentioned Cober about 15 minutes ago.
Mark, yeah. This young man to my right, yeah.
It was hard to hear exactly what you said, but I think you were saying that you have seen, or you have in your place of work, something that says Cober equals microservices. Okay. So I wouldn't necessarily say Cober is microservices. It might be Cober is SOA. But I do believe that if you understand distributed systems, it doesn't matter whether the embodiment of that distributed system is Cober, DC, an ESB, or microservices, based on Docker and Kube, for instance. And like I said in the presentation, I do think there's a lot of things that we are launching into because we like to do this in our industry. We're launching into with both feet and with our hands over our eyes, and thinking it's all going to be great, and forgetting all the bad things that happened in the past. So if you have people who know Cober and know distributed systems, they absolutely should be able to give their knowledge. I think it's valuable knowledge. They should be the ones that people are listening to. And I'm not saying that because I was involved in Cober. Absolutely not. There were some shit things that Cober did, okay? So I don't know if that answers your question.
There's a guy here up front, and then we'll go to you just a few rows back. Just here, 3 back from the front row.
Hi. I would like to know your thoughts on scalability more from a number of microservices and number of, as the team size grow. There were a number of, let's say, bad things that happened with SOA, for example, centralized governance and all those things that SOA is attributed to. When the number of microservices and the teams grow, how do you do knowledge sharing across the teams? How do you make sure that not everybody is, inventing their own way to implement circuit breaker algorithm and all of that? And as it starts to grow, you probably start to think about some centralized governance and the tooling around service discovery and service registry between the teams. So you're just wondering, is this coming back to the same kind of problems which SOA is attributed to?
Was there a question there?
I from my point of view, thinking about microservices from a perspective of how many do you need or anything is not the wrong way. That's not the right way to phrase the discussion. What you want to have is, for any given request and message flow, you don't want to pass that message around too much. So this is one of the things to build scalable distributed system in general. You don't want to, if you have a message that bumps around 10 places before getting a response, that's going to be slow and very hard to scale. So instead of doing that, you need to think about, okay, if I want to make this scalable, I need to think, well, maybe I need to put some caching, a little orchestration that allows me to cache the data at the microservice level, so that we can avoid some of those long chains of responsibilities. Thinking that a microservice is a table in my database, which a lot of people tend to do that. It's not the right model. It's not just a microservice is a table. That's not. I don't know if that answer your question maybe a little bit, but this is part of the discussion. How many do you need? How many you need? It's more about how many teams you have. So it's more about so for me, microservice is a way to scale an organization more than a way to scale my software. So it's depending on how many. If you say, well, I have 100 developers, so how many microservices do you need? Well, I would hope less than 100. Then it becomes complex to do stuff in general. But that's my point. I don't know.
I guess I have a interesting perspective. I used to be the chief architect at ITV, and I was responsible for a SOAR implementation in the early 2000s there. So at TES today, I sort of described I have 60 engineers, and what I have at TES today is 180 degrees from what I put in place at ITV. So we do nothing top down. I have no architects, like there's not a single architect employed at TES. The key thing that drives, I guess, avoiding duplication or not invented here within the teams is the fact that everything is visible now. So everything we do is in GitHub. Everybody sees every deploy. Everybody sees, new routes, new services created. There's kind of active discussion in HipChat, in GitHub issues around changes to these. Some of this is supported by the remote first culture where every conversation happens online. We don't go and sit in front of a whiteboard and have some abstract discussion about the architecture. It all happens online. And actually, it's incredibly efficient. I think when you bolt onto that, the fact that I probably don't have enough engineers for what the business wants to achieve. It's kind of a constraint of being in a business like mine, that their ambitions are huge, their willingness to invest isn't that huge. So we're constantly being forced to be really pragmatic. And as a result, people don't want to recreate. They much prefer to use others.
I have a little thing to add to that discussion. It's considering the fact that code, so if you're thinking about microservices, when you should not be attached to code. So code is a piece of thing that is there that should be thrown away as quickly as possible when it becomes obsolete. And this is the key point of a microservice system from my point of view, being able to innovate quickly and cycle them. So, which doesn't happen in a monolith. This is a major difference between one and the other. So a monolith is there forever. That's the concept of a monolith. You still have monoliths in Italy and Egypt and everywhere. Very good ones. But still, I don't know. I don't like too much software maintaining those type of things. But that's more or less, throw them away. So, and the GitHub thing, it's how pretty much.
Sure, there's a few traps that you need to be aware of and try and avoid as you're building that large team. Microservice promises that everyone can use their own development tools, their own stack, and their own language, and that's something that, although it promises, that's a huge trap to fall into. You've got to pick the technology that you're going to back as an organization, and you've got to understand what technology can be swapped in and out. So maybe you're prepared to swap the language runtime in and out, so different teams can use different languages, but you want to lock down your expertise on a certain platform, Kubernetes and deployment environment, but you want to make a conscious effort to make sure that platform is not tied to a particular deployment environment, like Amazon, for example. You don't want to build a team of 100 engineers who are only capable of building applications that you can deploy in one cloud provider or in one data center. So look for those traps. Organizationally, one of the implications of the two-pizza team and the small team size and the small size of a microservice is that people should be mobile. Once they've worked on one service, they can put it aside, they can move somewhere else. Take advantage of that to share the best practices across the team so that you have standard ways and standard knowledge of how to do everything.
Thank you much.
Question here from a gentleman just at the back here.
My question is about moving from SOA to microservices, and what do I have to give up, basically? I'll describe where we are. We've implemented service-oriented architecture around an orchestration engine, which is running on JBoss, and it's basically standards implementation. So we've implemented standards. So we've got W3C standards everywhere. What seems to have happened is that the world has given up standards. So we've moved away from W3C standards, and we're embracing a brave new world where XML has been replaced with JSON. And what I can see is that I agree with the last talk very much. It's about, I don't quite know where we're going into, but I know what we're leaving behind. And I don't want to throw babies out with bathwater. So of the standards that you can relate around service-oriented architecture, and particularly orchestration, orchestration standards, reliable messaging, discoverable services, schemas, which you don't get with JSON. All those things, of those things, would you retain anything in your new microservices environment?
So I'd ask you the question, which is, does it work for you today? Because if it does, why are you even thinking about moving? This notion of we need to do 50 releases a day, fine, it might work for some companies, it might not work for you. You might just want to go from being able to do one release every 18 months to one release every 3 months. That might be the cadence that makes sense for you, and in which case microservices might help you get there a little bit, but so could service-oriented architecture. It's not a case of everybody has to take microservices, just like everybody didn't have to take SOA. And I would seriously suggest you think about what it is you're giving up. And standards are really important. We already heard about, how you should architect so you can't get deployed onto a particular vendor. One of the nice things that standards give us, and let's not forget HTTP is a W3C standard, is it gets us away from vendor lock-in. Cloud is a really good way of moving back to vendor lock-in. I won't say more, but microservices at the moment, because there are, apart from HTTP, there is a lack of true organizational-based standards. There's a lot of open standards. REDHAT, open source from the get-go. Everything we do is essentially an open effort and can be considered an open standard. But true standards like W3C or Oasis, they are worth a lot to a lot of companies. So consider the benefits and the trade-offs.
Okay, thanks very much. I'd just like to make a closing comment there, and it resonates with what Mark was saying, is we spent a long time campaigning to make open source the core of what we do, and this move to web services and hosted cloud environments, we're going to go back to that world where we're trapped in an environment that we don't control. And my caution to anybody building modern applications is if you can't download it and run it on your laptop, you should beware. We'll break now for lunch. Back here at 2 o'clock when my buddy David O'Donoghue will be talking. Okay, thank you.